The time T until failure of a product is uniform 0, 10. An extended warranty pays a benefit of 100 if failure occurs between T equals 1.5 and T equals 8. The present value W of this benefit is given by this function. Find probability W is less than 79. Now, when time is between 0 and 1.5, and when it's between 8 and 10, then W is 0. And so here it is less than 79. So this interval and this interval will be part of our answer. But the main calculation lies in the other interval. Now note that they say that benefit is 100 when T is between 1.5 and 8. So you may think that, oh, okay, well, in this interval, it's never less than 79 because it's 100. So then why is the answer not just other two intervals where it's 0 and hence less than 79? Well, the benefit is 100, but that's not W. W is the present value of the benefit. And the present value is given by this equation, and that will be less than 100, and we have to find when it's less than 79. So when we are in this situation, when T is between 1.5 and 8, then we need to know what's the probability that W is less than 79. And W in this interval is 100 e to the negative 0.040. So 100 e to the negative 0.040 is less than 79. Divide by 100 and then take ln of both sides. And then when we divide by negative 0.04 on both sides, you know the inequality will get reversed because we are dividing by a negative number. So it comes out, this one comes out to be T greater than 5.893. And also don't forget that we are in the situation where T is between 1.5 and 8. So we will say over here that T is greater than 5.893, and also we know that T is between 1.5 and 8. Now when you combine these two, when we know that T has to be greater than 5.893, but it also has to be between 1.5 and 8, these combine and give us that T has to be between 5.893 and 8. And the probability of that is the length of this interval, B8 minus 5.893 divided by the total interval length, 0 to 10. And that comes out to be 0.2107. So now note that in this interval, when T is between 1.5 and 8, the benefit is always greater than 0 as well. Not only is it less than 79 with this probability, but the benefit in this interval is always going to be greater than 0, because in this interval, it's the present value of the 100 benefit. And no matter how far out you go in time, the present value of a positive sum of a positive amount will always remain positive. So what we can say is that here actually W is between 0 and 79. So the probability of W between 0 and 79 is actually the 0.2107 that we calculated. So as I remarked earlier, the W is 0 when T is in the first interval and in the third interval. The first interval was 0 to 1.5 and the third interval was 8 to 10. And so the probability of W equals 0, which is also a part of our answer because W equals 0 means it's less than 79. So that is found by dividing the combined lengths of these intervals over which it's 0 by the total length, which is 10. Total length, remember, was 0 to 10. And the length of this interval is 1.5, and of this interval is 2. So the combined length is 1.5 plus 2, and divide by 10, get 0.35. So that's the probability of W being 0. And now we wanted probability W less than 79. So that's equal to probability of W equal to 0 plus probability of W between 0 and 79. So W equals 0 was 0.35 over here, and W between 0 and 79 was 0.2107. We add the two, we get 0.56. That was choice D.